Hi, good morning and good afternoon, everyone. Thanks for joining us for this webinar by Severalnines, where we're also joined by our colleagues from Percona. And we have Tyler Duzern with us, who is a product manager at Percona, focusing on MongoDB. My name is Jean-Jérôme, and I'm joined by my colleague Rory Newman, who's a senior support engineer at Severalnines. And Tyler and Rory will be talking you through how to manage MongoDB and Percona Server for MongoDB today. And just before we get started, I wanted to run you through some of the logistics for today over the next few slides. First of all, to let you know that the session is recorded. If we can move to the next slide, Rory, and that you can ask questions at any moment by using the question section of your control panel. Throughout the next 60 minutes or so, and we'll take some time at the end of the webinar to answer any questions you may have, of course. And you can also contact us via email at info@severalnines.com during or after the webinar. If you want to continue the conversation there, we'll be happy to, of course, further engage with you if you have more questions on MongoDB, on Percona Server for MongoDB, or how to manage MongoDB with ClusterControl and or the Ops Manager, which is the main topic today. But just to begin with, on the next slide, I wanted to introduce you to Severalnines and ClusterControl. Just to let you know a little bit about who we are, if we move on a bit. Severalnines is a company that focuses on or specializes on automation and management of open source databases, and we focus on these four main areas that you can see here: the deployment, monitoring, management, and scaling. And we've packaged all of this into a product, ClusterControl, which we will talk about in a bit more detail today as we go through the session. But just very briefly, ClusterControl is broken down into these four areas. There's two versions of it: a community edition, which comes for free, that you can use to deploy, monitor, and also use database advisors with. And we have a commercial version also that includes the management and scaling features, but we'll touch on that a little bit more during the course of this webinar. And on this next slide, I just wanted to walk you through just give you a quick overview of what some of those features are around the deployment, monitoring, and management in particular, where you've got features that go from backup to database cloning to one-click scaling, configuration management, and so on. You can upgrade your databases automatically with ClusterControl. And on the next slide, just to show you also the databases that we support, which are the different flavors of MySQL. First of all, of course, there's the Percona versions of that as well. We support MongoDB, which is today's topic, MongoDB and Percona Server for MongoDB, and then also Postgres. So if you're using a mix of those three of the most popular open source databases, then ClusterControl is a good solution for you. And just finally, we have on the next slide, we have 32,000 plus users to date. You can see here some of our customers as well, spread across the globe and across different industry sectors. So I hope that gave you a good overview of who we are and what we do. But the topic today for the next slide is all around MongoDB and Percona Server for MongoDB, and how to manage MongoDB operations. And we'll look here at a more detailed view of the MongoDB Ops Manager and ClusterControl. And to kick things off, before I hand over to my colleague Rory, I wanted to ask all of you who joined us today whether you're currently using MongoDB yourselves. So it'd be great to set the scene this way. Whether it's MongoDB you're using or the Percona Server for MongoDB, or whether you're currently investigating and looking into getting started with MongoDB. It'd be great to get your feedback here. I'll let this run for a few seconds. And I'll just take the opportunity again to remind you that you can ask us questions at any moment, during the course of the session by using the question section of your control panel. But for now, I'm just going to close this now. I think most of you provided that feedback already. Thanks very much for that. I'll just close this now and share the results. Right. So that's a nice, interesting split. So it seems like a 50-50 type of situation almost. Half of you are investigating and looking into MongoDB, so that's great because I think you get some good insight into it today and how to manage it. And if you already use MongoDB, I think it'll be great for you to follow the session as well, because we're going to deep dive a little bit more into the MongoDB Ops Manager and also ClusterControl to show you how you can use either tool to manage MongoDB. So thanks for your feedback and for setting the scene this way. I'm going to close this now and hand over to Rory for the presentation.
Right. Okay. Thanks, DJ. Right. So let's get moving. So we're discussing how to automate and manage operations. An overview of Ops Manager and ClusterControl. Ops Manager, of course, in the official MongoDB tool, and ClusterControl from Severalnines. So let's just move on here. Okay, so first let's take a look at some of the features here. This is a high-level feature comparison. Let's see how they stack up against each other. So deployment initially. Both Ops Manager and ClusterControl can deploy any combination of MongoDB replica set or sharded cluster, or indeed, not included here, but standalone nodes, if that's what you need. They each take a different approach to configuration of initial deployments. Ops Manager offers a flexible dialog to set MongoDB parameters for the specific deployment, which allows you to tailor each individual deployment by hand immediately beforehand. It starts out with some moderate defaults that may or may not be suitable for your deployment, but you can modify them on the fly. ClusterControl takes a different approach and uses editable templates on disk on the ClusterControl node, which allows repeated node deployments that are guaranteed to be consistent. The templates can be edited by you prior to a deployment, so you can set whatever settings you wish for your deployments. You can even put the templates into what am I thinking of? A revision control software, so you have various different versions of your deployments if you wish, and drop them into your directory, your ClusterControl file system directory, and deploy the different releases as and when you wish. By default, also, ClusterControl offers you a choice between MongoDB's own MongoDB or Percona Server for MongoDB. Now, Percona Server is a free, enhanced, fully compatible and open source drop-in replacement from MongoDB. That includes enterprise-grade features and functionality, including support for Percona's own high-performance memory storage engine and for the RocksDB storage engine as well. Going back to Ops Manager briefly there, the version manager in Ops Manager has functionality that allows you to deploy custom builds also. So in theory, you could most likely use Ops Manager to deploy unofficial builds such as the Percona software as well. That's something that would need to be tested. Metrics. So the metrics monitored. Well, we'll look into this in a little bit more detail later. But both CloudControl and Ops Manager monitor both host and MongoDB specific detailed metrics. ClusterControl has a feature in addition called default advisors, which includes key performance related metrics. So I'll talk a little bit more about them next. And they both, as I say, have a customizable dashboards. So we're on custom dashboards. So yes, they both do custom dashboards. They're a key feature of any enterprise management system anyway, and Ops Manager and ClusterControl aren't any exception to that. Dashboards of key metrics are a feature of both, and any combination of dozens of MongoDB and host metrics can be selected. In CloudControl, the advisors feature is an advantage. It allows you to add custom metrics to your dashboards using ClusterControl's built-in Developer Studio. Advisors are written in the Developer Studio in a JavaScript-like language, which is documented on the Severalnines website in the ClusterControl documentation. And there are a good number of useful advisors provided already, which, while providing monitoring functionality, also serve as good examples if you want to write your own, or indeed modify existing ones for additional functionality. So, cloud or infrastructure as a service provider integration. Neither Ops Manager nor ClusterControl currently support integration with public cloud services for the purpose of deploying virtual infrastructure. So, such as EC2 instances, for example, in AWS, or Google Cloud Engine instances. Now, I can't say whether or not this is planned for Ops Manager in the future. I would personally suspect not, given MongoDB's Atlas service would be competing with it directly. Ops Manager's backup daemon does have the option, however, to store backup snapshots in S3, and it retains the backup metadata and the oplog data in a local database. As for ClusterControl, ClusterControl will have AWS S3 integration with backups in the next release, which is due very shortly, in the next 2 to 3 weeks, I think. And that will mean being able to automatically upload scheduled backups directly to S3 to take advantage of S3's, well, virtually unlimited storage, redundancy, lifecycle management, and of course archival to Glacier for long-term offsite storage. So that's the current state of the IaaS provider integration. Consistent backups. Now, consistent backups of busy databases can be difficult in any environment. In the case of a MongoDB replica set, it might involve traditionally freezing one of the nodes, taking a disk snapshot or a copy of the files on disk. If you have a replica set with 2 data-bearing nodes and an arbiter, that's kind of risky. It exposes you to downtime for the duration of the backup. If your primary crashes during the backup, you have nothing to fail over to. So some get around it, by adding a hidden slave, which can be expensive. You have to add an additional node to your replica set. Ops Manager uses the replication mechanism to keep an ongoing and up-to-date backup of your replica sets, which also facilitates point-in-time restore. Your backups are stored then in what's called a head database in Ops Manager, and snapshots are taken at scheduled intervals. So the interval is configurable, and so is backup retention. This does use, for a large cluster, can use quite a lot of disk space. It's configurable, but it does make up. So this mechanism, however, ensures that it can provide a fully consistent backup even across a sharded cluster. Now, ClusterControl doesn't maintain a running tail of the replication operations log of your MongoDB cluster, so we don't provide point-in-time restore, but it can perform fully consistent sharded backups using the Percona Labs MongoDB consistent backup tool, which for MongoDB 3.2 and above does a data dump of each shard and tails the operations log until the dump completes, so ensuring that no data is lost or missing from the backup right up to that point. In terms of your user and group management and LDAP, both ClusterControl and Ops Manager support LDAP integration, so you have your authentication federation, and they both support local user and group management also. So this can be accessed via the web GUI on either product or both, or in ClusterControl via the S9S command line management tool, which talks to the API, and we'll discuss that more later. Now, so secure installation. I don't know if there's any MongoDB administrators here who remember the slew of MongoDB ransom attacks where hackers gained access to MongoDB servers that were left exposed to the world in their default state, which was with no credentials set. So if anybody was caught out by that, you'll definitely remember it. By default, ClusterControl deploys MongoDB securely with credentials set. I say by default, it enforces it, and you have to set credentials. So that should give you some peace of mind, even if you've got an under-experienced junior admin setting up your database. It's going to be the credentials are going to be enforced. With Ops Manager, it doesn't enable it by default, but it does offer the opportunity to enable MongoDB authentication. You can set it manually when spinning up your deployment. And now, auto recovery. So what does it mean? So for our purpose, auto recovery means if a node crashes, a MongoDB replica set elects a new primary and continues on as normal, all going well. However, if a second node crashes in a 3-node replica set or shard, for example, you no longer have a quorum and writes aren't possible anymore. So ClusterControl will give you the option to have a database server restarted automatically on failure, which is often enough to bring it back up and allow it to rejoin your replica set. And it's not compulsory. Auto recovery can be enabled or disabled on a per cluster basis. And if it's configured, you can have it enabled or notify you of the crash, regardless of whether you have auto recovery enabled or not. So you can get in there and manually and hands-on do some work with it. Okay, on the bottom line here, so we're on the scriptable command line. I've alluded to it already anyway. ClusterControl offers a scriptable command line tool called S9S that exposes the ClusterControl API to the administrator by and large. So most of the management operations that can be performed at the GUI can also be performed at the command line. So your backups, user management, configuration, and starting and stopping your clusters, for example, can all be done from the command line and can all be scripted. It talks to the RPC API as well, which is another method of for developers of automating your cluster control tasks. So let's move on to how to get started with each product. So something a little bit more interesting than the dry stuff we've been doing in this slide. Okay, getting started. So installation of Ops Manager. So you can download it from MongoDB.com. In theory, it requires an enterprise MongoDB subscription. You can, however, download it regardless once you provide your details under an evaluation license. For production support, you require licenses for servers, the underlying MongoDB servers used with it, as well as your own licenses for your production servers. Production versus test deployment, as it's noted in the slide here. For the purposes of this this webinar, I have deployed a test MongoDB Ops Manager. The reason for this, and it'll become obvious in the next few slides, is that Ops Manager requires 2 replica sets on which it will sit for full functionality. So that's, in theory, I mean, if you're going for full redundancy, as recommended by MongoDB, that's 6 licenses for MongoDB servers just to support Ops Manager itself. So as you can imagine, a complex and a large setup. So we're going to stick with the test deployment. Test deployment is documented on MongoDB's website, by the way. It does take you through installing test deployment on a single server with most of the functionality available to you. So for ClusterControl, you can download it from Severalnines.com. To install it automatically, you download the installed CC script with wget or curl onto your local system. Make it executable and run it. It will install the required dependencies using your own package manager, keeping everything in sync. We have 3 editions, so Community Edition, Advanced, and Enterprise. Those are different functionality levels as well as different support levels. if you want some more detailed information on that, there's information available on the website, or give us a shout offline here. Email us or use to contact us on our website, and we'll be happier to discuss it with you. Right, so let's move along. Standard installation of MongoDB Ops Manager. Just to get to what I was saying previously about the complexity of it, this is a standard setup. You have your 2 replica sets there, fairly reasonably straightforward. Your application database, which supports your your application database, which supports your Ops Manager application itself. So it stores metadata about the application, any of your settings, for example. And you have the backup database, and the backup database, which is the head DBs, they're the head databases. These store your op log for the most part from your replication. So just to clarify that, when you are monitoring when you're backing up your MongoDB replica set or sharded cluster to Ops Manager, Ops Manager, as I said before, maintains a tail of your op log. Now, your op log is, for those of you who are not overly familiar with MongoDB, is similar to your binary log in relational databases like MongoDB. It contains an up-to-date record of the latest transactions on your database server. So Ops Manager tails this and writes those into the backup database, the head DB, so that in between snapshots of your database, it has an up-to-date. It has up-to-date details of the additional transactions, which essentially means it can provide point-in-time restore to a specific minute. So moving on a little bit more. So what's it like when it's highly available? It looks significantly more complex. Not really. You have two of them side by side, 2 installations side by side. You have a HTTP load balancer in front of them, ideally with some form of keep alive D or what have you, to ensure that you're always talking to the active one. These do not replicate between each other. This setup here takes 7 servers. Due to the write concern of MongoDB, having your application, one of your application database secondaries and one of your backup block store database secondaries on a single server might take out your system if there's more than one failure. Now, it shouldn't be a huge problem. You have here complete redundancy, so it should have to have multiple failures. But it might be a good idea to split those out as well for redundancy if it's critical to your use case. Moving on to cluster control architecture, you can see here it's a lot more simple. It uses a single MySQL or MariaDB database server on the back end, to which core services connect to store and retrieve the metadata. So redundancy can be achieved through deploying a database snapshot on a second node and installing the cluster control applications. You can put a HTTP proxy in front of them both, and requests can be directed to the live node. But if you're doing that, cluster control services such as auto recovery, for example, should be stopped on a second node to avoid complications. You can imagine if a node was being auto recovered by one node, the second node, being maybe potentially a few seconds behind it, sees the node as down and then attempts to restart it as well. You could end up in an infinite loop. So if you're looking to do cluster control in a fully redundant setup, please contact us, and we'll be happy to advise the best configuration for your use case. Now, installation. How do we install? So we've covered quite a lot of background now for both products, but there's probably no substitute really for seeing them up close and personal. So in the next stage, we're going to have a look at the the ClusterControl and Ops Manager interfaces and features. Ops Manager is quite a complex and time-consuming installation, so I'm not going to run through the installation on here. And I'm not going to run through the ClusterControl installation either, because I have a node up and running, so we'll get straight to those. But here we are for ClusterControl, the basics. For a test deployment here, typically what I would use is for t2.small, maybe EC2 instances, CentOS 7.3. This is what I'm using for the demonstration here today. So 1 node for ClusterControl, 3 for your MongoDB replica set deployment. And of course, as mentioned before, obtain and install the installation script, deploy a 3-node replica set, and review key functionality, which is what we're going to do. Moving on, the installation of the Ops Manager test. For the Ops Manager test, we're running 2 MongoDB servers, as well as a large Java application, which is the MongoDB or the Ops Manager application server itself. So we installed a t2.large here, which should be big enough for production use. It's got 8 GB of RAM. MongoDB recommend a minimum of 15 GB of RAM for a production server. And I'm going to use 3 t2.small instances for replica sets. So standard here is to obtain and install the MongoDB installation RPM and deploy 3-node MongoDB replica set is what we're going to do here. It's already installed for us, so great. There we go. Just to discuss integrations before we get into that. Because additional functionality like PagerDuty, New Relic, etc., is useful on an operations platform, especially PagerDuty, the likes of PagerDuty, and maybe instant messaging platforms such as Slack. Both Ops Manager and ClusterControl support a whole host of integrations with well-known tools. So they're listed here, but more information is available on the website about the specifics of the integrations. Now, let's have a look at the servers themselves. So we'll start by having a look at ClusterControl. I'll just jump in here. There, great. So, let's just jump back here. Here we go. So this is our ClusterControl database cluster screen. We've already got a MongoDB replica set installed, but we're going to deploy a new one, and then we'll take a look at some of the features. So to deploy a new one, I'll click Deploy. Note that you also have an import button here as well. You can import existing MongoDB clusters, both sharded clusters and replica sets as well. So we're going to deploy a new one. So deploy a database cluster. So as you can see, we also support MySQL replication, Galera, NDB, group replication, and Postgres, as well as MongoDB replica set and sharded cluster. So for the replica set, we need to provide a SSH user. ClusterControl connects to your servers via SSH, and you need to provide a key that can allow it to log into those servers. So I'm going to use my personal key here. The user you're logging into should have sudo access. You're logging in as, I should say, should have sudo access on the servers to which you are deploying. If you have passwordless sudo access for that user, as I do here, you don't need to enter a sudo password. Otherwise, you do need to enter the sudo password. So the SSH port, of course, is 22 byte, which is the default, but you can change it if need be. Just add a cluster here. We're going to deploy another Percona MongoDB. And down here, you have 3 options. Install the software, of course. Disable firewall and disable AppArmor or SE Linux, depending on your distribution. And we're going to go ahead and keep those enabled for now. It simplifies the installation and reduces the likelihood of a bad firewall config or a bad SE Linux config causing issues for us. So continue. Now, as you can see up the top here, vendors available are Percona and MongoDB. We're choosing Percona. We have version 3.2 here. and MongoDB also version 3.2. In the next release, due out within the next few weeks, we'll also support version 3.4. Now, I'm going to create the user here. So we're going to create the admin user, the admin password. As mentioned previously, ClusterControl won't let you continue if you don't provide these credentials. MongoDB.conf template, which is stored in the ClusterControl file system in the user share cmon templates directory. But this one defaults to MongoDB.conf.percona because we're installing the Percona server. So we'll keep that. Replica set name. Let's just do set 0. And repository. So we're going to use the vendor repositories. What you can do is use a mirrored repository. You can create a new repository which mirrors locally the repository of the vendor that you have chosen. Now, that repository is a mirror of the current state. It won't update by itself. And it's useful in the case where you want a consistent version across your deployments. So, and now we need to add nodes. So I have some nodes here for this. Prepared. So let's just take these. Add these in one at a time. And here we go. And now just click deploy. The activity viewer to watch what's going on. So here we are, preparing to create cluster. So let's expand that out a bit. And it's waiting for log messages, so we'll go to full job details here. So you can see it colorizes the different hosts here, so you know which host you're looking at. Starts off by detecting the OS, checking if the host belongs to a known cluster already. When some other checks to see whether MongoDB is already installed and whether or not it needs to remove it. And then it installed some basic dependencies. So tools such as Netcat and NumaCTL. And then it updates the package repository and gets started. So let's wait while this goes on. So in the meantime, that's going to install your cluster. That's just going to continue on there by itself. So let's have a look at MongoDB's Ops Manager tool. So this is the default screen you get once you sign into Ops Manager. For deploying, you get a choice of deploying building a new deployment, or manage an existing deployment. So similar to what ClusterControl will offer. So for our purposes for the moment, we're just going to look at building a new deployment. Okay, now you get the option to deploy it locally. You can, in fact, excuse me, you can in fact use MongoDB to deploy on your own laptop or desktop and have it managed by Ops Manager as long as it's running. Or you can deploy in another remote server. So we're going to choose the deploy in some other remote environment here because I have an EC2 instance set up for this. So all deployments will be built by default, it says here, with the latest production release of MongoDB, which is true. You can, in fact, change that. You can deploy whatever version you wish from the MongoDB or from the Ops Manager version manager. So that's not set. It's not set in stone here, but by default, it will deploy the latest production release. So we're going to create a standalone instance, but first I want to show you something. So let's create a replica set. So get a replica set 0, 3 nodes, and data directory prefix, so /data. That's standard. Go through here, you drop the drop-down menu, choose your distribution and version, select your OS there, and it gives you instructions for how to deploy it. So you would have to log in directly to the server and pull down the package, the agent package, using curl or wget, install it using your package manager, then edit its configuration and update these three parameters here. The group ID, the API key, and the base URL. The API key and group ID will change depending on your group. Actually, I was wrong. The API key won't. The group ID will change depending on your group. The API key is specific to the server. That needs to be updated for each deployment. So, for example, you will use the same group ID across all three servers when you're installing this replica set. But when you're setting up your next group of servers in Ops Manager, you'll need to use a different group ID. So pushing this out via, say, Ansible, Chef, or Puppet, you need to take that into consideration if you're not going to install the agent manually. So once we have these steps carried out and the data directory created and permissions set appropriately, we start the MongoDB MMS agent service. It's called the MongoDB MMS agent service because this used to be known as MMS before it was known as Ops Manager. It was MongoDB Management Service. It was at one time just a web-based service rather than a product which you could install yourself. So coming back to this screen, you can see here the server with the automation agent installed already exists, obviously. This other server doesn't exist, but because in a replica set, you have to have a minimum of one monitoring agent if you're managing it. It has a monitoring agent specified here. When the agent is installed on the next server, the server will automatically install a monitoring agent as well. You can also install a backup agent if you're doing the backups using Ops Manager. The backup agent and the monitoring agent there should only be one active per cluster or per replica set, but you should have more than one installed, and Ops Manager will choose which one becomes the active one. Now, back to deployment. So I'm going to do build a new deployment, deploy another remote. We'll just do create standalone here. Give it an instance of name, so just call it standalone for the sake of consistency, and continue. So here we are with our automation agent. The agent is verified. You can see down the bottom right-hand corner under the continue button. Click continue and deploy. And it will deploy the standalone server. This standalone, I should say, MongoDB server on the node. So when that's complete, it'll show up here. It's currently grayed out. We can view the agent logs here. We can see, so that should be done. In fact, go back to processes. Yep, your changes have been successfully deployed. Now, to have a look at this, no data available yet, of course, but this is the dashboard available. Some additional metrics down here. And there we go. And the same for your hardware metrics as well, your host metrics. So quite simple, quite straightforward. Now, switching back to ClusterControl. So the job is finished, our replica set is deployed. So we go back out here to the database cluster screen, and Percona MongoDB 2, as we just deployed, is now live. So if you look here, you get your auto recovery options. They're turned on for the cluster and at the node level. Controller is up and running. Each of the three instances of MongoDB in your replica set are up and running with no problems. So let's have a look at the overview. The overview by default gives you your op counter. So we haven't done much here with this, so the only thing we have here are commands, which is fine. You can also view asserts, cursors, global lock, network, wired tiger, cache, wired tiger, concurrent transactions. By default, that's all as normal. And further down the screen, you have the state of your individual nodes, including your global lock ratio and your lock queue, or your queued operations, your replication lag, and the number of connections versus the number of remaining connections. And server stats down here, then again, with your load average and your disk network traffic, your uptime. Okay, so the dashboard here can be modified. You can add additional graphs to this board by creating board, call it what you like, but choose any combination of metrics from the whole range of performance-related MongoDB metrics here. And merge them into a single graph if you like, or create multiple graphs. You can also choose for it to be selected as the default graph when you go to the overview instead of the up counters that we choose by default. Okay. Now, go on to the nodes tab here, so you can see each of your 3 hardware nodes here. Here's your overview of the nodes performance. So network errors, disk usage and utilization, swap usage, RAM usage, disk space, CPU usage, network usage, all standard metrics for these tools. Interface, we only have a single network interface here, but you can view all our individuals when you do have more than one. The same with the CPU cores. So you can keep track of your threading, whether something is running entirely on a single thread, for example. Now, Ops Manager, another useful tool. I don't have running operations at the moment. For those familiar with it, the operations monitor takes the status of db.currentOp in MongoDB, so it provides a full list of the processes running on the MongoDB server. So it gives you the time they've been running, the actual query that's running, the type of operation that's running, whether it's active or sleeping, the execution time, lock statistics, and the time taken to acquire a write lock or a read lock, and a description. Oh, and the ID, of course, on the client and server. Now, performance. So, MongoDB, we're talking about performance. The tool everybody knows, of course, is MongoStat. So we have that. We have the MongoStat output here again straight away. It's the first thing that most administrators will look at when they're trying to see where the load is on their system. We also have here an overview of the ops counters. So it splits out the original default graph, ops counter graph, into the individual types of operations. As you can see, there's very little here now at the moment because, of course, we're not running anything against the MongoDB server. And here, a key feature, advisors. Now, I've mentioned advisors before. The advisors are written in a JavaScript-like language, documented on our website, and they provide whatever information you want, and you can alert on them as warnings or critical warnings based on thresholds. So we do simple things here: collection lock, percentage, replication check, so replication lag, and then the replication window as well. So you can add custom advisors. Click on the custom advisors button. Here's your developer studio, and the standard ones are all in here, of course. You can import existing ones from somewhere else. You can add new ones here. Taking it from a template or whatever else. It's a very nice way of customizing your monitoring environment to take care of pretty much anything anything you need to monitor. We also have alarms, of course. That's a standard feature. My license will expire in 8 days. And you have logs. So it allows you to track running jobs on the server. The ClusterControl logs themselves. I've got a bunch of errors in here because it can't send a email message to me. That's fine. The mail server that I'm using is disabled. And error reports. So an error report, which you can create an error report. It takes all of the statistics from the server and bundles them all up for diagnosis. It's useful if you need to debug an issue with support, and of course system logs. So you get system logs as well. I don't have logs at the moment because I've just set everything up, so that's fine. And that's us there. Settings again, just to jump back down here. Your replication lag settings. you can set maximum replication lag, and you can set your DB stats collection interval, which improves the DB stats collection interval, improves the granularity of the information that ClusterControl has on your database server. So let's jump back into Ops Manager here briefly. We've got an alert up here. Just have a look. The monitoring agent is down. Yes, it is. Monitoring agent is down because we explicitly didn't deploy a monitoring agent, so we can acknowledge that, and that's fine. Go back to deployment. Here we are here. Our metrics are here. There's still no data available. We haven't been doing anything with the server, so that's why. But you've got some metrics here now available here. Let's take a final look here at backups. So it's an optional module which has not been configured, okay, yet, but you can configure it. The backup daemon requires a second database, potentially. It can require, depending on how you store your snapshots, you can choose to store them in a block store database, or you can choose to store them in file system storage. I've configured here a file system. So we'll just put this in here. File system path would be backup snapshots. That would probably work. Save. And here we go. So then it looks for your block store database then, just to install, or just to track the op logs. Sorry, excuse me. Just to store the op logs, so you can do your point in time restores. So it backs up up to date, continually tracking every operation on your database server. You have the option to use encrypted credentials. You have the option to use TLS SSL. That's fine. So that's backups. We don't have to configure this here now. Realistically, the backup server, the backups that MongoDB provides are a little bit, or MongoDB Ops Manager provides, are a little bit different to ClusterControl. Where in ClusterControl you can schedule your backups for any time you like, or you can perform a backup immediately. With Ops Manager, you create a schedule for your backups based on how often you would like to take a snapshot. So you can take one every 24 hours, one every 6 hours. The primary concern, other than disk space, is between snapshots, your backup is your op log that has been backed up. How long will it take to apply the op log once the backup is restored? So that's your primary concern there. So you might want to increase the number of snapshots to reduce the amount of time it takes to apply the op log once it's doing the restore. Now, and just to jump back quickly to ClusterControl, and we'll just jump into backups here. And you can see simply how to do this. So backup, we create a backup. Let's schedule a backup. That shows us specifically how to do that. So simple, choose every week, every day, every hour, whatever you'd like. We're saying every week on Sunday at midnight. Fine. So using UTC. You can choose MongoDB backup method of MongoDump or MongoDB consistent. MongoDB consistent, as I mentioned earlier, uses the Percona Labs tool, the MongoDB consistent backup, and provides a consistent backup even for a sharded cluster. So, and it'll store your backup on whatever directory you choose on your ClusterControl server by default, though you can also configure your backups for S3 in the latest version. Now, just a simple other change here. If we switch to advanced, your schedule uses the cron tab syntax for minutes, hours, days, month, and weekday as well. So now let's jump back out of this, and I think that's covered what we needed to cover here. So I'm going to hand you over now to Tyler. And we'll just jump back out here. I just find my slides again here. That's not it. There we go. And there we go.
All right, thank you, JJ and Rari. So I'm going to talk a little bit about Percona Server for MongoDB. Next slide, please. So what is Percona Server for MongoDB? It is basically a set of patches that Percona has built for performance and stability improvements layered on top of the MongoDB Community Edition code base. It maintains drop-in compatibility with the upstream version. So you can literally install this just by going to one of your secondary servers, stopping MongoDB Community Edition or Enterprise Edition, and then installing Percona Server for MongoDB on that instance and starting the service. And it'll reconnect and catch back up since it's compatible with the file structure and the configurations. First GA release was in December 2015. It provides us a place to develop new capabilities and storage engines that aren't available in upstream Mongo. And it also implements many of the MongoDB enterprise features, but does so in an open source release that's available for free. We also use it as a place to do expedited bug fixes for Percona support customers, and these fixes are then shared to the community in the next GA release. Next slide, please. So as I explained, it's a set of patches that are maintained on top of the MongoDB community code base as a base. You can kind of think of it as being community plus. So you can see bug fixes, performance improvements, enterprise features, and community contributed features. Next slide, please. Here's an example of some of the features that are available in Percona Server for MongoDB that are not available in the MongoDB Community Edition that's based upon. So we have enhanced security capabilities. This is part of the enterprise feature set. So things like auditing, log read action, LDAP authentication. We also support two storage engines that are not available in the Community Edition. One is the Percona Memory Engine, which is based off of the Wired Tiger storage engine, but in memory. Similar implementation to what's in MongoDB Enterprise Edition, and it contains full compatibility with the MongoDB Enterprise Edition memory engine as well. And then we've integrated MongoRocks, which we'll talk about a little bit more here in just a second. Also, we have native hot backup capability for both MongoRocks and the Wired Tiger storage engines. And we have some additional integrations around query profiling and other things for Percona Toolkit and the Percona Monitoring and Management tool. This helps you to do troubleshooting whenever you have either a performance issue or you're having some other type of database issue. You can do some troubleshooting with these tools. And in order to support that, we have enhanced query profiling. Next slide, please. So as I mentioned, we have MongoRocks integrated. What is MongoRocks? MongoRocks is RocksDB for MongoDB. It was added to Percona Server for MongoDB in partnership with Facebook. Facebook is the main driving force behind the open source RocksDB library. It's originally derived from LevelDB. It's built on using LSM trees instead of B trees for indexes and is append only. So this is optimized for like write heavy workloads where B trees are typically optimized for reads. It has native support for snappy LZ4 and zlib compression. So it's able to be a little bit more efficient about disk space usage. And the fact that it's append only means that regardless of the amount of available disk space, writes are always going to be fast because they're going to be written to the empty space at the end, and it doesn't fragment exactly. Writes go to mem tables first with MongoRocks, which is important to understand because that's how it maintains adequate read performance despite being write optimized. So reads will always be serviced from those in-memory tables first, if possible, before disk is approached. So if you have like a write then read operation, where you write something and then you immediately read back the same data, it's quite fast in MongoRocks. Compared to Wired Tiger, MongoRocks uses less disk space, maintains higher insert rates, and has better response times. And this statement, this assertion is based on some benchmarks that were done by Mark Callahan from the database engineering team at Facebook. And he gave a talk about this at Percona Live. But if you also want to check out his blog, Small Datum, he has a lot of the benchmarks there where he's compared MongoRocks to Wired Tiger. Next slide, please. And the enhanced query profiling feature. So Quan, which is a component of PMM, for MongoDB was announced at Percona Live Europe just last month. And it's based upon getting data out of the query profiler. So query profiling in MongoDB has some capabilities internal to itself to help you understand the way that your queries are operating within the database. However, the upstream implementation is based upon basically it being on or it being off. There is some filtering mechanics, but in general, it incurs pretty significant performance overhead. What Percona Server for MongoDB does is we implement an optimized query profiler, and then we also support setting rate limits. What that does for you is, as an example, you might want to profile all operations, but only take samples when a query is slower than 200 milliseconds or every 100th query that is less than 200 milliseconds. And so that's an example of how you would do that. What that does is it reduces the rate of sampling, which reduces the overhead, the performance overhead for enabling query profiling. And that's completely tunable. What this does for you is it gets you the data necessary to do trend analysis of query performance in Quan, and it also integrates with Percona Toolkit using the PT MongoDB Query Digest tool to get a report about your query performance and to identify your slowest queries. Next slide, please. So what is it all about? So bringing this kind of back together is, as we saw, Severalnines ClusterControl meets and exceeds the capabilities of the MongoDB Ops Manager. And Percona Server for MongoDB provides MongoDB Enterprise Edition features at no licensing cost and a fully open source release, with additional storage engines and performance improvements that aren't available in Enterprise Edition. So if you combine these two things together, what you end up with is you have similar or beyond the capabilities of MongoDB Enterprise Edition with Ops Manager at a reduced total cost of ownership while gaining additional features and capabilities. So I think this is a really compelling option for a lot of companies if they're considering deploying MongoDB. You can get the capabilities of the Enterprise Edition, including the management capabilities by using Severalnines ClusterControl with Percona Server. And the other nice thing is ClusterControl supports other databases as well. So if you're in a mixed database environment, which most people who run MongoDB are, it's very advantageous to you. Thank you for your time. I'm going to turn it back over to JJ and Rari.
Great, thanks a lot, Tyler, for for these highlights and features on Percona Server for MongoDB. We are almost on the hour, but we do have a couple of minutes for questions if there are any in the audience. Feel free to use the question section of your control panel to ask questions to Tyler or Ruri about what you've seen today. There's already a question here, so maybe we can start answering that. And that's for you, Ruri, but it's to ask whether ClusterControl works with the MongoDB Community Edition.
Yes, ClusterControl works with MongoDB Community, and it also works with MongoDB Enterprise. It doesn't deploy the SSL configuration for MongoDB Enterprise, but in general, it works with both.
Great, and as we just heard from Tyler, with the Percona Server for MongoDB, you actually get the enterprise features that are in MongoDB with Percona Server included, and in a type of community version there. There's another question here. Does ClusterControl installation require system root privileges?
By default, yes, it does. It may be possible to deploy it without root privileges, but that would be a manual deployment rather than the automated deployment that we provide. We can certainly assist with it. Certain activities and certain tools would require system root though during normal operation.
Great, great. Thanks a lot, Ruri. And while if there are more questions, of course, feel free to use the question section of the control panel to ask them. But maybe we can move to the next slide because we do have a couple of links to resources. In the meantime, so it's just a link here for you to download ClusterControl from here. So you can just go to severalnines.com, of course, and there's a direct link there to download ClusterControl. We also have a nice white paper on how to bring MongoDB to production. We saw at the beginning of this webinar that half of you roughly haven't, are investigating MongoDB at the moment. So this could be a good piece of content and resource for you to go through as you go through those investigations. And then there's a link here to go and download Percona Server from MongoDB, which of course Tyler spoke about just a few minutes ago. And we are just after the hour now. I don't see any other questions at the moment, so I think that we can wrap up for now. Thanks very much for your participation. We did record the session, and we make the recording and the slides available to you within the next couple of days. So we'll send you a communication once that's online. Thanks again to thanks Tyler, first of all, for joining us today for this joint webinar. It was great to have you, and thanks Rory for the presentation and for the demo, and thanks to all of you for your participation. We'll be in touch again with upcoming webinars, of course, but in the meantime, if you have questions on MongoDB or on Percona Server for MongoDB and ClusterControl, do contact us, and we'll be happy to talk about it with you. So for now, have a good rest of the day and a good week, and we'll talk to you soon. Thanks and take care. Bye-bye.